So for review for chapter 7, I'm going to choose the same example that we solved for the exercise. I just want to make sure that you know all of the steps for solving this question. So for this question, right, so let me just change the color. I don't want to use the same color that we already have here. So first we need to list all of the variable that depends on the question. So all the relevant variables. So for example, if the question said that the whatever, I don't know, the pressure depends on this and this and this, so you need to write down all of the variables that you have. So this is the first step. So the second step is to choose either FLT system or MLT system. I personally, not always, most of the time using the MLT system because it's too easier for me in comparison to the FLT system, but it depends on you. So when you have your MLT and you choose your MLT system, you need to look at all of the variables that you have and see if they have what they have. For example, if they have length, they have M, or they have T. Whenever you see one of them, then it's now count the basic dimensions. For example, this one has L. This D right here has L in it, so I know that there would be L for sure in it. This row is the kilogram over m cubic, right? So it means that it has mass. So this one has mass, but it still doesn't have T in it. So we don't need, I mean, we don't need to mention T yet. But here, when we are going to have viscosity or velocity, if we look at the dimensions, we also have it here. So there is a T here. So we have T there. So now we can say that our K number, our R number, which is the reference dimension, is 3. But if we have only, let's say we have only D and V, these are the only variables that we have, right? So this one has length in it, and velocity, we know it's x over t, which is length per time, right? So if we use MLT system, we just have L and T. We don't have M here. Then in this case, R is going to be 0, right? So be careful about that. But most of the time, it has 3 of them, L, M, and T. So, and then, okay. Now, if we go through the next step, so this one, we also need to consider all of the dimensions for the variables that we have, right? So we have D, we know the dimension is length. We're also going to provide all of the dimensions in the exam. So for viscosity, we also have that. For density, we have that, right? So now we need to count all of the variables that we have. For even if the one that is said that del P is depends on, for example, diameter, density, and this. We need to count that one as well. So here we have 1, 2, 3, 4, and 5 variables. Then it means that we have the K is 5 and R is 3. So from here, if we divided R from K, we get the number of 2. And this 2 is the number of the pi terms that we're going to have. So now let's choose the repeating variables. For repeating variables, we need to choose one for each of the reference dimensions that we have to kind of be a representative of that. For example, we have MLT, right? MLT system, right? So for L, I'm going to choose diameter, which has L in it, right? For T, I'm going to choose velocity, which has a T in it, right? And for M, I'm going to use density, which has m in it. We can also choose viscosity, doesn't matter, or pressure, doesn't matter, but we need to choose one of them, at least, to represent the mass, right? So now I'm choosing all of the repeating variables, and then if we want to write down to find the pi terms, right? We need, so these are all the three repeating variables. So I have the pi1, or also I can say that pi that represent the mu and the p. These are not repeating variables, right? So we can just write it down as uh, pi 2 or pi of the pressure and the del p, right? So this is how can we write it down, and then we just put the one right here, which is not repeating variables, and put the the power of 1. But the rest that are repeating has the power of A, B, and C, and we are trying to find them, right? And we know how to find them. We put M, L, T, and if we look at the left-hand side, which is pi 1 right here, we know that this is dimensionless, right? It means that it doesn't have unit, or it's 1, right? So it means that M, the power is 0, L is 0, and T is 0, because we know that whatever variables to the power of 0 is going to be 1. So this is how we consider that. And now we have one equation that we can just, and also we just write down all of the dimensions of all the variables that we have here, right? And now if we just look at this formula right here, right? We have a formula that has only M, L, and T. And if we look at the powers, we can just consider what is the power to what is the power is going to be, right? So if and if I write down for M, L, and T and look at the left hand side, all of them is going to be 0, and for right hand side we all need to look at these terms. And remember, if for example the T is in the denominator, then this power is going to have a negative, because it's when it's coming to the, for example, 1 over t squared, we know that it's t minus 2, right? So this is why we, for example, here, write it down, for example, here, L to the power of 3 to the power of b, it should be minus 3b, which I write it down here, right? So also be careful about these things. When you write it down, you need to solve for A, B, and C. Depends on which equation you have first. So when you find that, then you put all of that power into the first equation right here that you have, right? And then if we do that, right, so this is the pi term that we get. So we are going to do that for the other variables that are not repeating. So we did that right now for what was the variable? So we did it for PL, del PL, right? And now what else we have? We have the viscosity. So now we need to do it again for viscosity and then get the formula. And always don't forget to write down the final form, which is the first pi term is equal to the function of the rest of the pi terms. For example, if I have pi 3 as well, so I'm going to write it down as and poetry, right? So these are what, and also whenever you get the pattern, to make sure that you get the right answer, this should be dimensionless, right? So you put all of the dimensions for all of the variables that you have here and see if it's dimensionless or not. If it's dimensionless, so it means that you do all of the steps correctly. If it's not, you need to look at your calculation and look at the way that you solve it again. So, and that's it, I think, for the chapter 7.